Okay, here we are in episode 4. We're going to talk about flow fields. So, um, this is the foundation of our pathfinding. You would have seen, you would know in an RTS type game, we're going to have hundreds of units. So, we're going to need to be able to do pathfinding very fast and efficiently. Using the A star, you would know about that. Pathfinding, it's great for a single unit, finds optimum paths and all of that in milliseconds. But when we have 200, we're trying to do micro on our units. We can't do that, especially if you're trying to do like 20 TPS lockstep simulations or something like that. It'll just chew through all of your frame budget, and your game just won't run well. So what we use instead is we use flow fields to solve this. You run one search from the destination outwards, and then every cell in the grid gets a little arrow pointing in what direction towards the goal. Yeah, one search, thousands of units can just drive along the same flow field. So how flow fields work? Let's go. In our layer, we need to create a new script. It's going to be, whoopsie. What happened? Did I cancel it? Or, oh yeah, rename to flow field. Cool. Layer. Alrighty, so we just call it a class name of FlowFieldLayer. It's going to extend, of course, our iGrid. Oops. Okay. Now, let's just make a couple of things here. We're going to constant passability key equals passability, and we want to target, which is obviously where we're going to head to. Oh, I never did make the invalid, did I? We'll get to it. We'll get to it. Needs to be a var vectors. That's our array. Vectors. Then we're going to do an integration. That's going to be our packed float 32 array. Dirty full equals false. Use diagonals also equals false. So let's quickly make this invalid thing here. I think we can just call it a const invalid. All right. So the dirty flag is the key right here. Dirty. So this is the key. When passability changes for our grid, then we don't need to rebuild immediately. We just set it to dirty and we rebuild on the next update tick. So these batches are like multiple cell changes from a single frame, you know, instead of doing, if we do multiple things in one frame, we don't need to recalculate multiple times, right? We only need to do it once per frame. So on cell change, oopsies, void if target is valid, then dirty equals true. So we need to do, and now update, it's a delta, and that's float, also void. Okay. So if we are dirty and target dot is valid, then build target. Okay, so now the build method. This is our A-star algorithm. So function build, and we go from the goal to, so we go in reverse from the goal to our unit. So target goal goal dirty false. Okay, integration fill inf. Okay, for I in vectors size vector I equals vector 2's. So we just initialize that vectors, put them all to 0. If we're not in the inbounds, if the goal is not in bounds, bounce. We can't do anything. Easy. Okay. Passability layer equals grid layers get layer or null passability key. Right. Now passability key passability key. All right. That's that. Our open set is an empty array. Our goal index equals index of goal. Our integration is the goal index. Okay, so open and 0.0 goal like that. All right. Now what do we need to do? So we need to get our directions. So directions, grid coord, octal. If use diagonals, else grid coord Do I even have octoders? I didn't even define octoders. Yeah, right. Let's do that then, I guess. Cardinal octal. So octals gonna include diagonals in our set. So we're gonna have a -1, -1, which is northwest. We're gonna have 1, 1, which is +1 southeast. 0, 0, -1, -1, -1, -1, 1, which is northeast. Sorry, southwest. 1, 1, 1, -1, which is northeast. All right. Back to the flow fields. So while open size is bigger than 0, so we've still got stuff to look at, then open.sort custom func a b return a 0, 0 is b 0. Okay. Entry equals open pop front. Grab the first one off there. Too few arguments to push front because I want to pop it. I want to push it. Yeah. Drongo. Bar car cost equals entry 0. Var car index. IDX, yeah, equals entry 1. So if current cost is greater than the integration current index, then continue. We don't care about this one. So variable current grid coordinate from index current index width 4D in direction. So all of our directions for NB equals current add direction D. So we just get our neighbor. If not in bounds NB, means we're just on the edge, you know. We don't want to look at that anymore. So the neighbor cost is going to equal passability get cost NB if passability else 1.0. So if we don't have a possibility, everything's going to be 1. If NB cost equals continue, we don't know. Cannot infer the type NB cost variable cost of the value doesn't have a set type. All right. Now, so var step equals if dx is not equal 0, not equal 0, and dy not equal 0, else that's 1.0 without default. Yeah, the new cost is going to be the current cost plus the neighbor cost times the step. Okay. Cannot infer the type new cost because the values doesn't, well, okay, but bloody. Now, variable neighbor index equals index neighbor. Okay, if new cost is less than integration, then we've got a better path of our neighbor index. Okay, we've got a better path. So integration neighbor index is going to equal the new cost. Open, append, new cost, new index, and dx, and dx, dx, dx. Identify NB, dx, NB, dx. All right. So there's a few things here that we got to go through. Firstly, we seed the open list with the goal. And the cost is going to be 0, right? Not the start, the end, the goal. Okay? We're starting from the goal. We're working backwards. This is what lets one build answers the question which way to the goal for every cell simultaneously. Second, diagonal steps cost twice the cost. Okay, that's what our magic number here is, 1414. That's just Pythagoras's theorem, right? Okay, it's a diagonal step. A squared plus b squared equals c squared for every cell simultaneously. Okay. Now, secondly, a diagonal step covers more distance than a cardinal step. Okay. When we go diagonally, we're going further than we're going left, right, up, down. Okay. Thirdly, this is a custom sort. Okay. Custom sort. Where is my custom sort? We're doing a custom sort function here. Okay. Every iteration. This is our biggest performance weakness. We've got to sort this open set every single iteration. For grids that are under, like, I don't know, some kind of size, maybe like 100, 200 cells, we're probably going to be okay. When we're larger cells, it's not going to work, okay? This is not going to work. We can replace it with like a binary min-max heap, or something like that. But, you know, maybe later on we'll do a chunk episode where you like chunk up all of your grids when they're big. Yeah, we'll see. All right, so the vector paths. All right, our vectors for y in height, for x x in width. Variable c is our grid coordinate dot new x and y. Right. Our idx equals index c. If our integration equals inf or our integration equals 0, then our vector dx is our vector 2, 0. Assignment is not allowed. Okay, so continue. Our best cost so that's an our best direction zero for the in directions. Our variable neighbor c dot and direction b. If not inbounds neighbor, continue. Neighbor cost is going to be integration indx neighbor. If neighbor cost is less than our best cost, then our base cost is equal to neighbor cost. Our best direction is going to be in vector 2 d x d y normalized. Okay. Vectors idx equals best direction. Vectors idx. Yeah, so the two special cases, infinity, that means unreachable. Okay. So we'll have no arrows there. If we're vector 0, that means it's the goal. So we don't need an arrow because we're already at the goal. For every other cell, we're going to find the neighbors. And with the lowest integration cost, we're going to store the normalized direction forward. And then that's it. That's the flow. The reason we're going to do this is a second pass. Instead of storing the directions during the A star, we're going to do it as a second pass. Because we might update the cell cost multiplier multiple times during the search. We don't want to commit to a direction until we've got the final cost. Yeah. So we're going to need to be able to render this and visualize it. So we'll just make a renderer. And that will call the flow field renderer. Rightio. So it's going to extend a node 2D. Constant arrow color is going to be a color like 85, 0.0, and okay. And then we're gonna have a constant gold color. That's gonna be a color 0.3, 0.3, 1.0, 0.3, 0.9. Nice green. What have we done here? We've done something wrong. Alrighty, and then we'll do like the block color is going to be color 1.0, 0.3, 0.2, 0.4. Yeah, that's cool. We'll do a grid map, just grid map, and a flow field. We're going to go for setup, grid, avoid. So the grid, and we go the grid. Okay, the flow is going to equal grid, yeah, layer, flow. Then we're going to hue, the redraw, in our draw. We're going to, if not, grid or not flow, return yes, equals grid cell arrow and CS for X. So for every grid cell, we're going to just go get the coordinates as we always do. Grid coordinate new X and Y. I'm going to get the center, which is going to be grid cell to world. Our vector can equal the flow, yeah, vector. Did I miss something? I think I missed something there, but we'll come back to it in a minute. Costs equals flow get integration cost reward if cost equals infinity, then draw line center minus back 2, 3, 3 center plus vector 2, 3, 3 and draw line center minus vector 2, 3 minus 3 center plus vector 2, 3 minus 3 blocked. All right, and then I continue if the vec equals vector 2 0, draw circle center okay. Do a drawing, draw a line. Page B. Draw base tip below picture. Prep equals .32. Draw line base type tip. Okay. Okay. Rightio. We also need to add a node 2D here, and we call it flow field renderer. Cool. And flow field renderer goes there. Let's see, nothing. Why do we see nothing? Because we didn't set anything up, I think. Why? We need to go back to the test scene and set everything up. Okay. This is the layer, so it'll be the FlowFieldLayer. Yeah, we don't have many vectors. What are we doing? What are we doing? This is in our flow field layer. Build it. So we've got them and they're just all red X's, so we can't actually go anywhere at the moment. That's okay. So what we can add is an R. So when we press R in our input, we can go key R forward wherever, from wherever the world to cell get global mouse position, flow build code, flow render view redraw. There's already a variable name called yes there is, so we don't have to do the same thing again. Identify flow field. Okay, so what letter was it? So from R. Okay, so from R we should, doesn't really seem to be working, does it? Let's get into what is going wrong. And there we have it. We can just get rid of our breakpoints now. And we can press R and it will blow up. That's not good. Maybe we didn't fix it yet. There we go. And that's our flow. Alright, so in the next episode, we're just going to do like a fog of war. There'll be 3 states there for a hidden and explored and a visible, and like it'll take a double buffer design. So we draw and then we flip the buffers so you don't see it flickering. So it'll be pretty much how the classic RTS shroud effects work. Should be very satisfying from a visual moment because yeah, it's really cool. All right, so that's it.